Welcome to the FactoryHelp channel, Low-Pressure Radial Fans. Now, FactoryHelp spare parts. Supply will present centrifugal fans and explain their operating principles. The flow gets aspirated in parallel to the impeller, but gets pushed perpendicularly, thus creating a 90-degree angle. If we observe its components, we'll find the inlet flange, which always integrates a protective grate. The inlet cone, designed as a venturi tube to increase the speed of entry flow. Then, we find the impeller, located inside of a snail-shaped structure in sheet metal. This design increases the centrifugal factor. The transmission shaft, with its relative bearings, moved by a system of pulleys connected to a belt, activated by a three-phase electric engine. As we can see in the animation, the engine activates the pulleys, which causes the transmission shaft to spin. Pulleys have a different diameter, and they have the task to transmit energy and decrease engine revolutions. A minor speed translates to a bigger strength, so an increase of the torque, the shaft, makes the impeller spin, creating a centrifugal effect in its core. The flow arrives perpendicularly to the axis of the impeller, which distributes the flow radially, creating a type of vortex. The flow, helped by the spiral geometry of the structure, is directed towards the exit hole at a higher pressure, which allows it to travel greater distance through a piping system. The impeller is the main component of the fan. Its shape ensures different performances and uses. The radial blades fan is the most resistant structure for its field. They are made to be durable, resistant, and powerful, useful to move big quantities of air where they reach very high pressures. These fans have a very low maintenance cost, and they are perfect for an initial cheap solution. The airfoil fan, similar to the ones we find in airplanes, has the best performances with the lowest consumption. It can be used in environments where there are hard, abrasive, or harmful dusts, but the fan must be made of special materials. The industrial fan with reverse blades shows up with a minor number of longer blades made of sheet metal with constant thickness. It's a cheap solution with a lower performance. They are used for air renewals and small quantities of dusts. Industrial fans with forward blades are characterized by a higher number of small blades close together, facing the direction of the rotation. They can move large volumes of air at a low speed, and they are recommended for applications where a constant airflow rate or an air delivery with constant pressure is necessary. Industrial ventilation systems are a combination of different products, mainly a fan, which can be axial or centrifugal, and a piping network for gas passage from the outside to the inside, or vice versa. With an industrial ventilation system installed, there is an important feature to take into account. That is, how much gas do we want in our plant to carry? To know this value, we have to calculate the flow rate of our plant, namely, the volume of gas that the fan moves in a certain period of time. In the international system, flow rate is measured in meters squared per second. The formula to know the flow rate of an implant is very simple. By knowing the speed of the carried gas, namely V, and multiplying it for the width of our piping, namely A, we obtain the flow capacity expressed in meters squared per second. Knowing this value for ventilation systems is essential. It helps us understand whether we are installing the correct product for that determined process. Let's assume we have to run a spray booth, which uses burners to generate hot air. Burners need a right amount of air to work optimally. Let's suppose we install an industrial fan with a flow rate of 400 cubic meters per second, and we realize that the maximum temperature level in the booth isn't reached, causing disruptions in production. This means burners don't get the right amount of air they need, a problem that can be solved with an appropriate adjustment to the ventilation system. In order to obtain a higher airflow rate, two factors require an adjustment. To install a bigger and more powerful fan and to replace the pipes with a larger width, the flow rate will be greater by running the burners at maximum power. Confidence comes from knowledge. Learn with us. Become an expert in industrial solutions.